Hey guys, how's it going? So we are going to talk about double angle identities. And now I'm not going to go into too much depth to prove it because these are actually pretty easy to prove. Since they are pretty easy, I'll talk about that. Just one second. I thought something beeped at me for some reason. I don't know what beeped at me. Okay. So they're pretty easy to prove because what is sine 2a? Actually, I'm just going to scroll up here just a bit here. Well, sine 2a is alpha plus alpha. So alpha and beta are the same thing. So if I go to the sum identity, which either you took for granted it was true, or you can go through my proof. And if A and B are the same thing, this would just be sine alpha cos alpha plus cos alpha sine alpha. And these are just both the same. They combine together, and you get 2 sine alpha cos alpha. So that's where that one identity comes from. So this is where the 2 alpha comes from. Just a quick little easy proof. The cos one comes from a few different things. You can see here that it starts off pretty easy, right? So if I do the same thing with the cos 2 alpha, which is going to be the same as cos alpha plus alpha, and then I could just find when the cos alpha, so it ends up being cos alpha times cos alpha. So that's where the cos squared comes from. And then it's a minus 1, yep. Sine alpha times sine alpha. So that's where this other part comes from. Okay. So, not minus. It's minus sine. Okay, so that's where this identity comes from. So we know these two. The other identity below it comes from using the Pythagorean theorem identity, which says, I'll just write that right here. Sine squared alpha plus cos squared alpha is equal to 1. Right? Using this and rearranging it, solving for like, say, cos squared alpha, so you go to 1 minus sine squared alpha. And if I substitute that into this other equation, so I take this piece here, and I put that into this equation up here, I can simplify that down. It ends up being, in this case, that'll end up being the second one here. If I rearrange it for sine squared alpha, which is be 1 minus cos squared alpha, and then do the same thing and substitute it in there, I get the second equation. So they all come from each other. The tan one works the same way as the previous one. You just have to tan alpha plus alpha, plug it into one of the identities for that, which would be tan alpha plus tan alpha. That's where the 2 comes from. And then they got 1 minus tan alpha times tan alpha, and that's where that comes from. So that's a pretty easy one. Okay, so we should be able to recognize these now. So you should be able to see them quickly. Be like, okay, if I see 2 sine cos, that just means that's just the same as saying sine 2 times 45. It's a double angle identity. Alpha ends up being the 45, and this will end up being sine. The 2 disappears. The 2 is part of the identity. It kind of jumps into the brackets here. So it'll be 2 times alpha, 2 times 45, which is sine 90. Okay. It just says solve it as a single trig. You can determine what that number is. It's positive 1. I'm not too worried about that. The next one here, let's see what we have here. Got cos squared minus sine squared. So look at my formula sheet, try to find that. Usually if there's a square in it, there usually is a identity to go with it. So this looks like it's going to be the same as cos 2 alpha, where the 5 is your alpha, because they both have to be the same here. So this ends up being 2 times 5. Now there's no degrees here, so this will just be 10, probably 10 radians. That's fine. And it'll be the same as cos 10. Okay. So we're just going to verify these. We don't have to prove them because we kind of proved it up there to show where they came from, but we can verify them as well. We could show that if I put in sine, and I use my alpha as 30, 2 alpha is going to be 60. I just want to show that these two sides are the same thing. Put a 30 in there. That's degrees. And then that's a bad cos there. That's weird. Okay, so sine 60, using my unit circle, sine 60, you should know this one, is root 3 over 2. Sine 30 is a half, which we're going to use here. And cos 30 and a half is root 3 over 2 as well. Okay, so we're going to simplify down the left hand, or so the right hand side here. So half times 2 is 1. This just ends up being root 3 over 2. This is root 3 over 2. So that verifies that one's true. For at least 30. We can go through and try to find one that doesn't work, but we're not going to try. We're going to do 5 pi over 3. So like I said, I don't like using radians because it's kind of hard. Sometimes they're like, oh, is that, where does that land? What's the reference angle? I know the reference angle is going to be 60 degrees because of the over 3 part. But I do like to know which quadrant it lands in for sure. So I'm going to go 5 times 180 divided by 3. So this is the same as saying 300 degrees. Now that's going to be important. I didn't worry about it over here because everything was in the first quadrant. But knowing what's negative, what's positive here. So 300 degrees, 60 degrees. So this point has a positive x value of a half and a negative root 3 over 2 y value. Okay. Ooh, okay, this is going to be fun. Okay. It's going to be easy on one side, but tan 2 times this alpha, which is going to be 600 degrees. We got to find out where that lands. And then we have tan 300 degrees here. 1 minus tan squared of 300 degrees. You can put the 5 pi over 3 in there too, but it doesn't really matter. Okay, so 600 degrees is going to double up there. So I want to figure out where that lands. So 600 minus 360, so it's 240. So 600 degrees lands in this quadrant down here. So reference angle is still 60 degrees, so that's good. Oh, what I don't just happened there. Okay. But because we're in this quadrant here, my x value is negative. My y value is also negative. Okay. So tan is going to be, remember what tan is, it's y over x. On your formula sheet is sine over cos, and sine is y, so it's y over x. So it's my y variable divided by my x. So this is going to be, on this side, negative root 3. That's my goal, to get that now. Nope, positive root 3, because they're both negative, sorry. Positive root 3. Over here, we got 2 times negative root 3 divided by 1 minus negative root 3 squared. Okay, let's simplify this down. So I got negative 2 root 3 on the top. On the bottom, I have 2 minus 3, which would be negative 2 root 3 divided by negative 2, ends up being root 3. So it worked out, verified nicely. Ooh, a bit trickier. Okay, so I want to verify to see if this one is true for this angle. Negative, doesn't matter if it's a negative. I do want to know what it is though. Negative 5 times 180 divided by 4. This angle is negative 225 degrees. 2 of those, because I'm going to use that later on, I'm just going to times this by 2, is negative 450. Okay, so I'm going to write those over here so I know which quadrants they are in. So 225 is going to be in this quadrant down here. Okay. Oh, negative 225. That's positive. Negative is going to round backwards, going to be in this quadrant up here actually. So this is negative 225. And then the other one 90 straight up and down, but it will be, what will it be? It'll be negative 90, so it's going to go straight down. Right there. That's a negative 450. Straight down. Okay. These negatives are really kind of messing me up a little bit. That's fine. If I'm going straight down, my x value is 0, my y value is negative 1. That's going to be useful. And this is a reference angle of 45 degrees in this quadrant, which will make my x value negative root 2 over 2, and my y value positive root 2 over 2. Okay. So now I have enough information to solve this question. So cos, I don't know why I wrote those so far over there. Oh, well, whatever. Cos 2 alpha. Cos, actually I'll write this up. Cos negative 450, that's going to be important. This is going to be cos negative 225 squared, and then this one's going to be sine squared of negative 225 as well. Okay, so cos is the x value. The x value is 0. Good. Okay, so we have to make sure it ends up being 0. Cos squared, so cos is the x value. The x value on this one is negative root 2 over 2. And then over here, I got sine being squared, and sine is the y value, which is just root 2 over 2. Both being squared, so they're both positive numbers. This will end up being 2 over 4, which is a half, minus 2 over 4, which ends up being 0. Cool. And there we go. That's the end of that one. So we're just verifying it there. Not too bad. Proving it was pretty easy up here, just replacing it. In the next part of this lesson, we will be proving our lesson, or the next lesson will be proving these. So not verifying them. Verifying is nice and useful to determine, should I prove it, right? Or should I just give you a counterexample and say, yeah, they're not the same. Yeah, I'll talk about that in the next video. See ya.